In the realm of robotics, a comprehensive exploration. Chapter 1. The Dawn of a New Era. In the nascent dawn of the 21st century, a revolution began brewing, one that would fundamentally alter the relationship between humans and machines. Robotics, a field that had once been merely relegated to science fiction, started stepping into the limelight, captivating the imagination of engineers, technologists, and the public alike. The prevalent enthusiasm surrounding robotics stemmed from its multidimensional capabilities, ranging from simple automated processes to complex systems designed to assist in intricate surgeries. Institutions worldwide began to invest substantial resources into this burgeoning field, leading to radical advancements in artificial intelligence, machine learning, and sensor technology. The narrative of robotics cannot simply be reduced to its mechanical aspects. Instead, it serves as a vivid tapestry woven with threads of innovation, ethics, and philosophy. At the core, robotics grapples with questions of existence and human identity in a world where machines could, in theory, perform many tasks that were once exclusive to people. How would society adjust to these transformative changes? Would robots complement human abilities or render them obsolete? As concerns about job security arose, discussions about the ethical implications of robotics gained traction. Ultimately, these discussions would serve as a crucial backdrop for the evolution of robots. Companies began to realize that public perception played a significant role in the acceptance of this technology. The quest was not merely about creating more sophisticated robots, it was about fostering an environment where people would embrace them as partners rather than threats. To this end, educational initiatives and community engagements were launched, ensuring that upcoming generations understood the potential benefits as well as the limitations of robotics. Chapter 2. The Spectrum of Robotics. Robotics is a diverse field, yet it can broadly be categorized into industrial, service, exploratory, and social robots. Each category emphasizes different functionalities and serves unique purposes. Industrial robots often dominate factory floors, performing repetitive tasks with precision and speed. From welding to assembly, these machines exhibit remarkable efficiency, alleviating the strain of labor on human workers. Companies can boost productivity, reduce errors, and ultimately create cost-effective manufacturing processes. However, this efficiency is counterbalanced by concerns over job displacement. Service robots, on the other hand, venture into domains that interface more directly with human experiences. They range from vacuum cleaning machines that ease household chores to robotic assistants designed for elderly care. The technology that enables these robots is complex, integrating sensors and computer programs to allow machine learning capabilities that adapt to individual users. For instance, consider a service robot tailored for an elderly person. It learns daily habits, recognizes speech, and can assist in medication management. Such innovations symbolize a shift towards companionship, as these robots are designed to enhance quality of life rather than merely serve functional purposes. Exploratory robots, like those used in space or underwater missions, present another vital frontier. They are engineered to navigate environments perilous to human life, engaging in research where humans cannot readily access. The Mars rovers serve as exemplary models of this category, equipped with instruments to analyze geological samples and search for signs of extraterrestrial life. Each data point gathered contributes to our understanding of the universe, and can drive future space exploration missions. Lastly, social. Robots are becoming integral to our daily lives, taking on roles that require emotional intelligence. These robots interact with humans in a more nuanced way, using facial recognition, dialogue systems, and empathetic responses to create connections. Their development raises critical debates about trust and emotional bonding between humans and machines, thus prompting further philosophical contemplation about artificial intelligence and the nature of companionship itself. Chapter 3: Robotics in Healthcare. Advancements in robotics are profoundly reshaping the healthcare landscape. Surgical robots, such as the renowned Da Vinci surgical system, enable surgeons to perform minimally invasive procedures with unprecedented precision. With a three-dimensional visualization system and robot-assisted instruments, surgeons can undertake complex operations that would be difficult or impossible through traditional means. Such innovations reduce recovery time and post-operative pain for patients, emphasizing how robots can significantly enhance human capabilities. Beyond surgery, robotics in healthcare extends into rehabilitation and therapy. Robots designed for physical therapy assist patients in recovery through guided exercises tailored to individual needs. These machines are not just tools, they embody a sensitive understanding of patient dynamics, adapting to their progress and setbacks. This synergy between technology and human care epitomizes the potential of robotics to collaboratively enhance patient recovery. Robotics also plays a crucial role in diagnostics, particularly through the use of automated systems in laboratories that expedite test results. These robots can quickly conduct thousands of analyses, allowing healthcare professionals to focus more on patient care rather than time-consuming tasks. The integration of automation in diagnostics further ensures that healthcare providers receive accurate data swiftly, enhancing decision-making and treatment pathways. Nevertheless, the intersection of robotics and healthcare is not without challenges. Questions arise regarding data privacy, the ethics of robot-patient interactions, and the universal accessibility of these technologies. As robotics become increasingly embedded in healthcare, stakeholders must address how to construct a framework that safeguards patients while maximizing benefits. Chapter 4: Industrial Robotics and Automation. The realm of industrial robotics has experienced significant transformations paralleling advancements in technology. Factories worldwide have embraced automation to revitalize their production lines. The integration of artificial intelligence, AI, and machine learning into robotic systems has enhanced their adaptability and precision, enabling them to tackle increasingly complicated tasks. With cobots, collaborative robots designed to work alongside humans, production is more harmonious. They do not just replace human efficiency, they enhance it, taking on hazardous tasks while allowing humans to engage in higher-order thinking and management roles. One pioneering development within industrial robotics is the creation of robots that can learn on the job. By leveraging machine learning, these robots analyze previous tasks to optimize methods, significantly reducing downtime and error rates. The ability to analyze patterns and adapt operations signifies a pivotal shift toward more intelligent manufacturing environments. Workers may find themselves collaborating with intelligent machines to innovate rather than simply maintaining traditional roles. However, as industries rush to adopt these technologies, significant concerns arise about skill gaps. As automation takes center stage, questions of employment and worker retraining become critical. Organizations must ensure that their workforce is equipped to engage with sophisticated technologies. Upskilling potential employees not only preserves jobs but also fosters a culture of lifelong learning where creativity and innovation thrive. Moreover, automation in factories also introduces considerations related to sustainability. Companies are under increasing pressure to minimize their carbon footprints and resource consumption, and robotics offers pathways to meet these challenges. Robots equipped with energy-efficient technologies can optimize supply chain logistics, reducing waste through effective inventory management, which aligns with the global movement towards sustainable manufacturing. Chapter 5: Educational Robotics and Teaching. The automation and robotics revolution extends into education, shaping how future generations will learn and interact with technology. Educational robotics promotes STEM, science, technology, engineering, and mathematics skills in children. By engaging in hands-on activities that require coding, design, and problem-solving, students develop critical thinking skills that are essential in our increasingly technological world. Robotics in education goes beyond mere technical know-how. It fosters collaboration and creativity. Programs are designed around teamwork, pushing students to come together to solve complex problems while navigating group dynamics. Such environments encourage collaboration and foster a sense of belonging among students. The importance of interpersonal skills, for example, effective communication and teamwork abilities, has become paramount in the modern educational landscape, and robotics serves as an engaging platform to cultivate these strengths. Advances in simulation technologies further enrich educational experiences. Virtual environments allow students to test robotic designs and algorithms without the need for physical components. This not only reduces costs but also encourages experimentation. Students can tweak their designs repeatedly in a low-risk setting before moving to real-world implementations. Programs like LEGO Mindstorms or Vex Robotics provide modular kits that inspire creativity in a fun, accessible manner. However, the shift toward robotics in education poses challenges. Teachers, often underprepared for these technological innovations, require training to facilitate programs effectively. The integration of robotics education not only demands curriculum changes but also investments in teacher development. Addressing these challenges head-on will ensure that educational robotics will benefit future generations, rendering them prepared for a landscape defined by technology. Chapter 6: The Ethics of Robotics. As robotics penetrate deeper into daily life and industry, ethical considerations come to the forefront. The design and deployment of robots raise questions surrounding autonomy, accountability, and moral responsibility. Consider autonomous vehicles, which have garnered significant attention in recent years. While the prospect of self-driving cars promises to reduce traffic accidents, the ethics surrounding decision-making frameworks in critical scenarios remain a divisive issue. Who is responsible if an autonomous vehicle is involved in an accident? Is it the manufacturer, the programmer, or the vehicle's owner? These quandaries necessitate a broader discourse on ethics, emphasizing the importance of clear guidelines and standards to govern robotic behavior and capabilities. Policymakers, engineers, and ethicists must unite to explore frameworks that prioritize human safety, accountability, and ethical guidelines in robotics. Society must establish trust in robotic systems to ensure their successful integration. A lack of transparency and accountability can cultivate widespread apprehension. Moreover, the role of bias in artificial intelligence poses ethical dilemmas. Algorithms deployed in robotics often reflect the biases present within the data they are trained on. This has profound implications, particularly in fields like hiring and law enforcement when algorithms perpetuate discrimination. It becomes essential for developers to understand these biases and cultivate practices that promote fairness and equality in machine learning. As questions surrounding ethical conduct in robotics proliferate, the need for diverse perspectives becomes apparent. Ensuring that varied voices, including those from different gender, ethnic, and socioeconomic backgrounds, are included in discussions surrounding robotic design and implementation can lead to more holistic solutions that benefit society as a whole. The promise of robotics is enormous, but with that promise comes commensurate responsibilities that individuals and organizations must confront. Chapter 7: The Future of Robotics. Looking ahead, the future of robotics remains both promising and uncertain. Rapid advances in AI and machine learning will continue to push the boundaries of what robots can achieve. In time, we may see fully autonomous robots capable of intricate social interactions and decision-making processes, blurring the line between machine and human capabilities. Such developments bring with them opportunities for efficiency, convenience, and creativity, but also complexities that challenge our notions of work, agency, and morality. In manufacturing, organizations may fully embrace adaptive robotic systems, capable of self-calibration and real-time decision-making. These intelligent factories will optimize production lines dynamically, reducing costs and enhancing agility. The agile manufacturing landscape will require a workforce with diverse skills, emphasizing creativity and problem-solving to navigate an environment in which one might work alongside intelligent systems. In healthcare, advancements in robotics could lead to more personalized medical care, enabling robots to anticipate patient needs and respond preemptively. This shift will transform healthcare delivery, making it more efficient and tailored to individual circumstances, enhancing recovery and minimizing hospital visits. Additionally, robots may take on roles in mental health treatment by providing companionship or stimulating cognitive functions in ways that were previously unimaginable. As robots become integrated into everyday life, society's understanding of work will also evolve. The fear of job displacement may shift toward a focus on how to leverage human-machine collaboration. Instead of predicting mass unemployment, discussions may center around creating roles that enhance human creativity and empathy, skills unparalleled by machines. New professions may emerge that require oversight of robotic systems, emphasizing the creative and synergistic relationship between humans and automation. Finally, as we stand on the precipice of an exciting era in robotics, it is essential to remain vigilant about the inequalities and ethical questions that robots can amplify. Addressing these challenges requires collaboration between technologists, ethicists, policymakers, and communities. Only then can society harness the transformative potential of robotics while ensuring that human dignity, creativity, and ingenuity remain central to the narrative. Conclusion: embracing the symphony of robots and humanity. Robotics represents more than just cold metal and screws, they embody humanity's ambition, creativity, and ingenuity. As we tread this uncharted territory together, it is crucial to maintain a balanced view of robotics. The path forward lies in embracing robots as partners, as tools designed to complement human advantages and open new frontiers of possibility. Our narrative with robotics is still being written, and while the challenges persist, the promise is brightly visible. This evolving relationship will redefine industries, reshape education, and even alter human interactions. The endeavor to facilitate ethical practices and incorporate perspectives into decision-making frameworks is crucial to steering the future towards an inclusive society, where robots enhance the human experience rather than detract from it. Ultimately, robotics serves as a prism through which we can examine our values, priorities, and potential futures. In this exciting era, we must engage actively, question fearlessly, and endeavor collectively to create a world that harmoniously balances the mechanical wonders of robotics with the rich emotional tapestry of human culture. Together, we can craft a narrative where machines do not overshadow the beauty of humanity but rather empower it to soar to unprecedented heights.